Technology. Advancing at an unprecedented pace. As our machines become smarter, autonomous, and more capable, so does their potential to be hijacked and used against us. It's a real problem, and you may ask, who is standing in the way of our adversaries, intent on attacking our own systems and turning them against us? The U.S. Army Tank Automotive Research Development and Engineering Center, or TARDEC, that's who.
Whenever you're giving control over to a computer, cybersecurity is definitely going to be a concern. We certainly don't want hackers or our other adversaries getting into that system and getting control over it.
TARDEC is hard at work, making sure we're one step ahead of the bad guys and ensuring the U.S. military has the battlefield advantage. To truly secure these robotic systems, you have to understand their potential vulnerabilities. One way TARDEC scientists do this is through penetration testing, and in this demonstration, researchers use a robotic system that communicates wirelessly with a controller. They will exploit this connection in an effort to take over control and simulate an attack. Using open source tools from the internet, this researcher sniffs the network traffic and decodes the wireless passphrase. She exploits this information by launching a man-in-the-middle attack that secretly altered the communication between the robot and the true controller.
I need to stop it from just acting as it normally would.
Ultimately, TARDEC is developing autonomous systems while at the same time focusing on cybersecurity to ensure these systems are trustworthy, giving commanders more options, requiring less human capital.
So we'd never want to have our soldiers be in a fair fight, and heck, it ain't a fair fight if it's a soldier against a robot. Okay, so the whole thing is, if your adversaries are pursuing robotics and autonomous systems in the ground domain, and they are, we don't want to have our soldiers face that threat. So we need not only to develop them ourselves, but understand how to employ them, because then you'll learn how to defeat them as well. And so that's that sort of asymmetric advantage I absolutely want to give to our soldiers.
These scientists and researchers, armed with science, are advancing autonomous robotic systems and the cybersecurity technology that protects them. And with 50,000 miles under their belt, this is just the beginning.
Really cool. They have these big, huge robots, sort of like Skynet from Terminator. So you can actually program scenarios into the robots where you could do like a hostage scenario where one of them in the middle is a hostage and you have to shoot the ones around them and they'll bum rush if that one gets shot. So they're all talking to each other. They're really cool because it puts a lot more of the here's how hard it is when a target's actually moving into it. They were just kind of moving around, so you have to make sure you think you need to lead them, but then you don't because you remember how fast bullets are. So you got to remember to breathe, and it's a whole different discipline than when you're sitting there taking nice controlled breaths and doing it. You're like, okay, I got to remember to breathe, got to remember I'm moving. So, but most of the old guys have had some kind of experience being shot at, being in firefights. And with the way AFSOC EOD is going, we're hoping to be involved in more of those kind of forward action type missions anyways. With that being the case, we're going to need to hone these skills so that they don't have to worry about you and they can take care of their mission, you can take care of your mission. It needs to be second nature so that you don't have to worry about learning that while you're worrying about doing your job in a new scenario. As many things as can be second nature should be second nature.
This particular robot is the PackBot Fast Tag. And as you can see, it has a camera arm and it also has a gripper arm. The camera arm has a 300 zoom on it. So if they're on a convoy and they want to see what's in front of them, they don't have to drive right up on top of it. They can send that robot out and it has a 300 zoom, so even from a distance it can zoom in on whatever it is they're looking for. So if it's a bucket, they can see, okay, it's just a bucket, or they can say, hey, no, it's something else underneath there. If they can't tell just with the camera what it is, they can drive up on it and they can use that gripper to manipulate if there's a bucket or a bag or some kind of a debris over it. They can use the gripper to move it out of the way and then use the camera to see what it is. That way it determines right then and there, does EOD need to come out? Because and it can also has a hidden manipulator arm that can move small things out of the way. So if you're driving or walking, if you see something you're not sure, instead of sending somebody up there to move it out of the way, they can just use the gripper to pull back the burlap bag or the piece of board or whatever it is to see if there's actually anything underneath there. They pretty much can operate in all terrain. None of the robots are waterproof. They will function in rain, but if you start getting them into like deep water, they're electronics. They're going to fail. The terrain it dictates a lot. Most of these robots are line of sight, so as long as you're within a distance, if you're going over a mountain or a hill with the robot, you're going to lose comms with it. So for the most part, they're all line of sight, but there is some leeway with that. I like doing it because it's something that comes in that's broken, and a unit needs it. It's an asset. It's like a rifle. It's like your vehicle. These units need this to function. Just like any Marine unit, any Marine infantry unit, you need a radio to function. Without a radio, you can't.
Oh no, these are going to be embedded into the missions, and as they go out, when there's a situation arises where instead of putting a person on the ground, a robot can do its job, save the soldier, save the government money, get that trooper home. That's our main goal, is to get the trooper home.
DARPA's Robotic Autonomy in Complex Environments with Resiliency program, known by its acronyms RACER, recently conducted its third experiment to assess the performance of off-road unmanned vehicles. These test runs included the first with completely uninhabited racer fleet vehicles, RFVs, with a safety operator overseeing in a supporting chase vehicle. The goal of the RACER program is to demonstrate autonomous movement of combat-scale vehicles in mission-relevant off-road environments that are significantly more unpredictable than on-road conditions. The multiple courses were in the challenging, unforgiving terrain of the Mojave Desert at the United States Army's National Training Center, NTC, in Fort Irwin, California. As at the previous events, teams from Carnegie Mellon University, NASA's Jet Propulsion Laboratory, and the University of Washington participated.
3, 2, 1, mark! Launch it!
Additionally, researchers from the Army Research Laboratory demonstrated the flexibility of the Performer team's autonomy software, critical to transitioning RACER capabilities to the services. This completed the project's first phase. RFV robots include 360-degree range and image sensing. These include multiple LiDARs, stereo camera pairs, color and infrared imaging cameras, radar, event sensors, and inertial measurement sensing. Computation tools have multiple best-of-class graphical processing units, GPUs, in an environmentally protected, shock/vibration-proof, and thermally managed electronics box, e-box that's specifically engineered for the demands of the RACER high-speed off-road terrain expected in DARPA's tests. The sensor and e-box combination currently collects 4 terabytes of sensor data per hour to support artificial intelligence, machine learning-based autonomy algorithms, and stack approaches required of fast-paced combat maneuvers in complex terrain. Modifications for roll protection, sensor/e-box integration, autonomous control, and increased 7 kilowatts of power are included in each RFV. The RFVs are housed on a Polaris RZR S4 1000 turbo-based drive-by-wire platform.
Copy on the run, stand up.
Coming to DARPA is like grabbing the nose cone of a rocket and holding on for dear life.
DARPA's a place where if you don't invent the internet, you only get a B.
A DARPA program manager quite literally invents tomorrow.
We are thinking about innovation unconstrained. Where can we go?
Predict what is emerging as threats.
We're looking for the applications that seem impossible.
That passion will be saving lives 5, 10, 15 years from now.
Coming to work every day and being humbled by that.
The innovation and collaboration, it's a team effort.
We're not builders of the ultimate technology.
It's the engineers and scientists at the companies and universities that we fund that ultimately are going to bend metal and write code and deliver these capabilities to the warfighters.
DARPA is not one person or one place. It's a collection of people that are excited about moving technology forward.